Okay, this meeting is being recorded, so the usual disclaimers apply. But we're very happy to have everybody back again in this group, hoping to expand it with additional sessions, maybe once every month. I am your new organizer for the group, Sujit Mello. In the past, Jesus Aguilar has been the organizer, and he's obviously did a very good job when pre-COVID when you were meeting in person. I know there were a number of events that were had in the office. He's kind of moved into another team at Microsoft doing a secret project. So he asked me to take over the group. He's still in the New York City area, but so we're hoping to get him to come to one of these meetups and catch up with him and catch up with all of you soon. But in the meanwhile, I'd like to introduce Kendall Roden, who is graciously offered to get us all caught up on the latest and greatest Azure service these days, which is Azure Container Apps. And she is a senior PM in that team in Azure, and we're very fortunate to have her here today. So Kendall, go take it from here.
Yeah, thanks, Sajid. I appreciate it. Thanks for having me. So hi, everyone. As Sajid mentioned, my name is Kendall, and I'm one of the product managers for Azure Container Apps. And prior to joining the Azure Container Apps team as a product manager, I've worked at Microsoft for almost 6 years, all in field-facing like customer roles. So working directly with enterprise customers, smaller customers to implement cloud-native solutions, specifically using Azure, but a lot even in the past couple of years for customers looking at multi-cloud and using Kubernetes as sort of a platform that allows them to abstract some of the cloud-based deployment so that they can get consistency across cloud providers. So big fan of open source and a big fan of Kubernetes. And so super excited that I was able to take some of my customer experience and put it toward this new preview service. So I'm just curious, for those of you who have joined using Teams, if you can raise your hand if this is the first time you're really getting any kind of insight around the service. If this is you're fairly new, this would be introductory for you. Go ahead, and if you can use the hand raise feature, that would be great. Yeah, okay, so we see a couple people. 4 people have their hands raised. So does that mean that we have some other people on? Okay, 5. It's around 50% of people. This is going to be introductory. So if you can go ahead and put those hands down, that would be great. Thanks for all of that. And then anybody here who's been playing around with the service a little bit more, pretty familiar with it, seen maybe a presentation in the past? Okay. So we got one hand. I'm thinking maybe some other people weren't able to get to the hand. So it seems like in general, it's a fairly new audience. Richard, that's great that you have a little bit of experience. Hopefully today we'll all walk away with a really good foundation for what Azure Container Apps is and why it was created. And then, I would love for this to be interactive, so please feel free to interrupt me as we go. To be honest, I do this presentation a lot, or have done this presentation a lot. Oh, thanks, Richard. Yes, he's stalking my presentations. I love it. I have done this presentation a lot, so it makes it a lot more fun for me if I can be interactive with all of you and you have questions. So no pressure, but also a lot of pressure. Please ask questions. So let's just start out by getting a fundamental understanding of what Azure Container Apps is. So one of the things that we've seen, and I specifically saw when I was working in the field, is that we see customers time and time again who are interested in getting the flexibility and scale that Kubernetes provides. And obviously, Kubernetes is very much has gone through that sort of hype cycle. I feel like at this point, it's really reached a level of maturity and become the de facto standard for container orchestration, which is exciting. However, it's not necessarily super easy to adopt. So while a lot of customers are excited about the opportunity to use Kubernetes and the technology and what it provides, it can sometimes be challenging for them to actually adopt. And in collaboration with that, right, not even just adopting Kubernetes, but adopting containerization, adopting microservices, all of that has a lot of barrier to entry, especially for smaller organizations or smaller teams. And so at Ignite last year, which I think was October, November timeframe, we announced the preview for Azure Container Apps. And essentially, if you're familiar with Azure, which I assume most of you are because you're at the Azure Meetup, we have a lot of really great platform as a service options that really focus on abstracting away infrastructure and making it easier for app developers to focus on what they do best, which is writing application code. And that platform as a service model has worked really, really well, specifically for Azure App Service. So a lot of customers use this service to run their web applications. It has really deep integrations with other Azure services on the platform. It makes security, networking, app configuration, securing secrets a lot more streamlined because it integrates with a lot of other capabilities like Azure Key Vaults. And then it has, deployment slots where you can get more of that blue-green deployment model, test out a particular version, swap the slot, and bring one into active. And so with that being said, we wanted to bring some of those management capabilities and some of that really great work we've done on the PaaS side to the Kubernetes space, because we found that, hey, if we can maybe lower the barrier of adoption, customers can still leverage Kubernetes from a platform perspective in order to get scale and some of that portability that they so desire, but they can also offload a lot of the operational burden to us. And so that's essentially where this was born. And it does run on top of Kubernetes, so we are hosted on top of Azure Kubernetes Service, the managed Kubernetes service that that Microsoft provides. So what I love about this is it's just an example of us being able to use some of the great, container as a service or, infrastructure as a service plus type of offerings in order to add an additional layer of management for customers that makes it easier to consume the platform and utilize some of the features. So it's built on open source. We focus on application development instead of that infrastructure, which we've seen being like a progressive movement to serverless over the past several years. And then obviously our goal is to provide the best possible portability stories so that customers who run in Azure Container Apps could hypothetically take their workloads that are running in the platform and move them to Kubernetes if for whatever reason they needed, additional capabilities that maybe they can get on an open source or managed Kubernetes platform that they can't get within our more PaaS focused model. So let's dive a little bit deeper into the platform capabilities and some of what we actually provide to customers and able to support this more managed offering. So one of the things that we focus a lot around is this serverless model for containers. So we do have a couple of different services within the Azure portfolio that provide serverless capabilities, right? So we have Azure Functions, which allows you to scale based on requests and really have that consumption-based pricing model. We even have things like Cosmos DB that can run in a serverless model that are much more consumption-based. And that model works really well for a lot of customers because it optimizes resource utilization, which is main request that we get from a lot of customers. So how could we bring in some of the things we've learned from Azure Functions and some of these serverless technologies and marry it with containers? And you see the first iteration of this with Azure Container Instances. So I feel as though that's probably the most, I think we actually did an Azure podcast, which Sajit and I are co-hosts on the Azure podcast together. And I was a new product manager for container apps, and I actually called it Container Insights, or I called it Container Instances. We do have Container Insights too. So, the list never ends. But I understand from a portfolio perspective, right? We can all get a little tongue-tied here. So Azure Container Instances did kind of introduce that serverless container model into the Azure platform, but it doesn't have support for things like service discovery or auto scale. And so we wanted to bridge the gap and use some of what we learned from that serverless model, but bring it into more of a microservices type of architecture. So we can run your containers serverlessly based on HTTP traffic or any scaler that's supported through the Kubernetes event-driven autoscaler. So I'm going to dive in a little bit deeper to what that project is. It's an open source project that can be deployed directly onto Kubernetes, be it a managed service or the open source Kubernetes offering. And it allows you to scale your application containers on metrics that are more event-driven. So think things like MongoDB, MySQL events, Postgres, RabbitMQ queues, Azure Service Bus topics, Event Hub. So there's a ton of different sources that you can use to basically trigger application autoscale. And if you're familiar with Kubernetes, you probably know about the horizontal pod autoscaler. And the goal of the horizontal pod autoscaler is to essentially scale horizontally instead of scaling vertically. So we scale the number of instances of the application running on top of the Kubernetes platform. So We use this in a lot of our demos that are distributed, right? Because we have an Azure service bus that does all of the distributed communication. We have a publisher and a couple of subscribers, and this allows, microservice best practices by not doing direct service-to-service syndication. And what's neat is we can basically scale those subscribers based on the number of messages coming into the topic. So that's baked directly into our manifest, and you can easily deploy your application using these capabilities without having to change any of your application code or do any sort of open source Helm chart deployments. Another thing is the scale to zero and the serverless capability also allow you to optimize cost. So not only are you getting better utilization, you're also only paying for what you use. So in container apps, essentially the way that looks is, let's say I have application code running, let's call it the order service. And I say, hey, when I don't have any traffic coming to that order service and the CPU threshold has fallen below, a certain number, which we've specified in our pricing docs, then we basically charge you nothing and we scale that application down to 0. If you need that application to scale back up, the challenge there is you incur a cold start. So we have introduced this concept of idle containers, which allows you to essentially scale to a minimum replica count, maybe let's say like 1 or 2 containers running at all times. And once they fall below a certain threshold for traffic and CPU, they're billed at a lower rate than a running container that's actively taking requests. So this is a little bit different than the AKS, the Azure Kubernetes service model, where you pay more for the compute, and then you can just optimize that compute and run as many pods within the within the limits of what you're able to do. I think on AKS, maybe there's like a pod maximum of 100 or 150 per node. But really what you're focusing on in Azure Container Apps is more the number of replicas versus the underlying compute, since it's more of a serverless model. So if you haven't played with Kata, once again, it's that open source project. It has over 35 event sources that it supports for scaling purposes. And so, if you were, for example, to port over to Kubernetes, or even AKS, they have a managed add-on. So even though it's not baked into the platform, there's still ways you can get that portability if you were to move to Kubernetes in the future. So wanted to talk about the different scaling options that we have. So I mentioned HTTP, and here you can see an example of how you would specify an HTTP scale rule within your container app manifest. So basically I can say, hey, based on the number of concurrent requests, I want you to scale the application, and you can set a minimum and maximum replica count. So that should be pretty familiar if you're used to HTTP scaling in Kubernetes. And then we have 3 other options. So one is that event-driven model where you can basically specify a custom scaler. And then we have CPU and memory. So you can specify, hey, when CPU hits a certain threshold, I want you to scale up the container, or scale out the container, and so on and so forth. So this is what scaling looks like within the platform. And once again, it's baked right in. There's nothing you have to do in order to configure this. You can use it out of the box. And you can also, I'm assuming mix and match. Exactly, Richard. Yeah, you can use whatever you want for the respective container apps. Now, one thing I'm not sure about, and I actually need to check on this, I think, you know what, I'm not even going to speak to it just because I'm not 100% sure. I'll take a look at the manifest. I'm not 100% sure if you could run like a CPU scaler and an event-driven scaler on the same container app. Like I would assume that you can, and I'm almost a little embarrassed that I don't 100% remember the answer to that. Maybe it's just because I haven't played around with it myself, but I do believe that you can. And I think I have some examples of it. I just need to make sure I check the manifest so I'm not mixing things up. But at the minimum, you definitely can specify like a scale rule per container app. But I believe you can also specify a mixture of the two. I just need to make sure that I confirm that. So I'll get back to you with a confirmation there. So, in addition to providing that event-driven model and the scale out, we do a couple of other things to really enhance the developer experience when using Azure Container Apps. So, we obviously support a variety of different workload types, microservices, API endpoints, event processing workers, background jobs. Now, I will say we don't necessarily support native cron jobs today. So if you needed like a job that runs on a schedule, we don't necessarily have a way for you to deploy a container app specific job. You could use Dapper to do that, which I'll get into a little bit, but that's just something to consider. And then also I should update this slide because we do support web scenarios as well. So being able to run web apps. So that's something else to consider. We obviously support any container that can basically run on Kubernetes, with the exception of we're a Linux-based platform. So that means right now we don't have support for Windows containers. So while we don't, enforce any specific programming model or base image, we do require that you run Linux containers at this point. Would be interested in getting feedback around Windows containers. It's not currently on our roadmap, but who knows? As the service evolves, that could be a priority for us. And then we do have GitHub Action integration. So the ability to basically set up a continuous deployment pipeline that allows you to trigger, updates to your container apps based on your any code changes within your repository. So I'm super excited about Dapr being built into our product, and I'm curious if anybody who knows what Dapr is or has used it before could raise their hand. It would be great. I would love to give a quick overview, but just want to see if anyone has prior experience. So we know Richard, he's an expert. So we've got Richard. Let's see, anybody else? Okay. So it seems like Dapr is a fairly new concept. So I would love to do a little, a little Dapr overview for you, just so you have a bit of an idea of what it is. So essentially what Dapr allows you to do is offload some of the responsibilities that you typically have to plumb into your application code to run microservices, and you offload that to a sidecar called Dapr. Dapr stands for the Distributed Application Runtime, and so now I'm going to tell you a little bit about how this works. So when you're building microservices, there are a lot of things you have to think about that you don't have to think about when you create just like a single application where all of the code is running in a single process, right? Like when you introduce microservices, you have to think about like distributed communication. How do you do service discovery? How do you do high availability? How do you make sure that you do, like I said, decoupled communication? How do you make sure that you have distributed tracing so that you have visibility into how your application works together, and any failures that happen in one particular microservice might actually have ramifications to actions taken by other distributed parts of the application. And so I think we can all agree it's we have to think about fault tolerance. Like there's a lot more things that get introduced when you're doing like a network distributed application versus a single monolithic application that's deployed as a single process or container. So as we start moving to microservices, we start having to bring a lot of this plumbing code into our application. So for example, let's say we're back to that order service and we're using Service Bus. If I want to decouple communication and I have 5 or 6 microservices that are all communicating, I would have to implement the Azure Service Bus SDK in all 6 of my microservices. I have to make sure that my developers actually know how to use that tooling and instrument their code. I have to think about how I'm going to do things like circuit breaking and retry logic. And that can be challenging, and it distracts developers from focusing on business logic, which is really what make all of our companies or money, right? And allow us to really focus on the cool, neat, innovative things from a logic perspective. And so you can take microservices that are running in any language on any framework, obviously within container apps focused on Linux containers. And then through this communication via HTTP or gRPC, your application will talk directly to a Dapr sidecar, and Dapr will handle some of these responsibilities for you. Things like service-to-service invocation, state management, publish and subscribe communication, resource bindings and triggers. So things like Azure Functions where you can do input and output bindings. Like, for example, one of my microservices needs to output a receipt to blob storage anytime an order is placed onto Service Bus. Instead of having that output, and that communication directly from your application to Azure Blob Storage, instead you can say, hey, I'm going to offload that responsibility to the sidecar, and through an HTTP or gRPC endpoint, I'm going to trigger that output binding, and Dapr will handle the actual facilitation of that output. We support actors on Azure Container Apps and within Dapr open source. Observability, so that distributed tracing concept. The one thing in Azure Container Apps that we don't support today as a building block is secrets. So we do support secrets within your container apps, but we don't support Dapr secrets. So that's just something to be aware of, for customers who are used to using the open source product, they would have to make a couple of modifications to their existing components. So You can deploy this anywhere, but we have actually deployed it right on top of AKS and baked it into our offering. So here's how this would actually look running in our environment, just to give you a visual. So I have my order service here. I have my Dapper sidecar, and my order service is talking to the Dapper sidecar through HTTP or gRPC. And you can see here, these are basically those APIs that offload that responsibility. So for example, service-to-service invocation, we'll take a quick look here. So instead of, like I said, calling directly from order service to basket service, which introduces tight coupling, what I can do is use Dapper service-to-service invocation. So I can say, hey, I want to use the service-to-service API, which is v1 invoke. And then I basically want to tell it which application am I trying to invoke in this case. In this case, it's cart, but let's say it would be basket. And then we pass in the name of the method that we actually want to invoke on that service. For state management, instead of calling directly to something like Cosmos DB to manage distributed state, I can say, hey, Dapper, please go to my state store, which could be any number of components, and I want you to retrieve item 67 from the inventory state store. And I'll explain how this is configured in just a second, but that's essentially how that works. So you have this standard API that you can bring into your application code to remove some of those, those dependencies. There are also SDKs you can use. Yeah.
Sorry, there were a couple of questions in the IM window. One was about how does Dapper fit with Open Service Mesh, and whether there's any plans to work with Oleans, which of course is a completely different product that we have for actors.
Yeah, no, those are good questions. So abstraction from underlying implementation using Dapper as the abstraction layer. Yeah, exactly. From an actor's perspective, it's really going to be dependent on Dapper. So I'm not sure what Dapper currently has implemented. I know that it follows the Orleans pattern, but whatever is available in the Dapper version that we support will be what we as container apps support. And then how does Dapper fit with Open Service Mesh? So Dapper and Open Service Mesh have some overlapping capability. So service meshes are really focused more on the networking aspects and don't necessarily have any of this abstraction of state or secrets. However, Dapper does provide some service mesh capability in that you can enable things like MTLS through Dapper and service-to-service invocation. However, Dapper does not support things like traffic splitting, which you could only get in a service mesh. So you can use the two together, which we see some customers use, or if you're really just using a service mesh for maybe MTLS, then perhaps you could use Dapper and forego using Open Service Mesh. But keep in mind, Dapper, in order to get the MTLS, you have to actually implement these APIs in your code. So not all customers want to do that, whereas Open Service Mesh, you can use that networking model without the Dapper application integration. So, and there's also really great docs on dapper.io about how Dapper, compares to a service mesh. So definitely recommend checking that out. So what's nice about this and about Dapper is that you can switch out the implementation on the back end, which removes some of that tight coupling of the actual technical implementation. So for example, if I'm using that state API called inventory, I could have an inventory component that's representative of DynamoDB, Azure Cosmos DB, and I could switch those out, and all of a sudden my application code is working with a new state store without me having to make any code changes. So that's one of the really nice things here. Okay, awesome. So that's a little bit about how Dapper works. I'll skip the rest for now, just because I want to give you more of an overview of container apps, but I'm super excited about Dapper being baked into the platform, and I'll spend a little bit of time at the end showing you a Dapper demo where you can see how it's actually instrumented and what it looks like in the application code. So let's talk a little bit about the last point here, which is Azure Container Apps being built on open source, right? We've talked about Kubernetes, we've talked about Kata, we've talked about Dapper, and I want to call out here too, right? Dapper is totally optional. So while it is available and baked into the platform, you have full autonomy over whether or not it's enabled or if you want to use it or not. It's by no means a requirement. Other applications without Dapper should still be able to communicate with one another. And the reason that is because we handle all of the ingress on your behalf. So if you think about Kubernetes, you obviously have to go in and deploy your applications, but then you also have to think about deploying services, which will either internally or externally expose your applications running in your pods on Kubernetes. And then you think about, okay, how am I going to manage ingress externally, right? So you usually have some kind of ingress controller, which does things like path-based routing. I did a lot of work on path-based routing today, so it's a nice mouthful. But usually we'll see customers who have some kind of ingress controller in addition to Kubernetes services and their application containers. And it can be quite arduous setting all of that up and managing it yourself. But we provide that to you by enabling Envoy within our container apps environment. So Envoy allows all of your applications to be able to communicate with each other in a secure manner within your container apps environment. And then within that, we actually support this concept of revisions, which allows you to do traffic splitting across multiple revisions of your container app. So for example, if we go back to that order service, let's say that I make a modification and I change my container image, I can actually deploy that change and get a second revision if I'm running in multi-revision mode. And then I could do A/B testing or blue-green deployment by slowly draining traffic off of version A and sending traffic over to version B. So this is something that you would usually get in a service mesh on Kubernetes, but we're managing for you on the platform. So in Azure Container Apps, we don't have any concept of like a bring your own service mesh or bring your own ingress. It's all baked into the platform as part of that platform as a service model. So are there any questions around these areas before I dive a little bit more into container app environments, revisions, anything like that?
It looks like Tony may have a question. Tony, you can get off mute if you want to ask directly.
Sure, that'd be easier. Can you say a little bit about how persistence is handled? So could you set up persistent volumes? How does that work?
Yeah, Tony, great question. So right now we don't support persistent volumes, so it's really focused on stateless workloads. Stateless being, intra cluster state. So we don't have that concept of mounting volumes at this point. However, we will most likely introduce like a V1 of persistence, which will be Azure file mounts. So that'll be the first area of focus, and then we'll consider persistent volumes in the future. There's some ramifications to obviously like the availability of that, the backup, especially across availability zones and things like that we want to manage or that we'll be managing for you. And so it's just something that still has to be fleshed out from an implementation perspective.
Got it. Thanks.
Yep. Thanks for the question. So I wanted to talk a little bit about this concept of environments because we've talked a little bit about container apps high level, but it's like, okay, how does this all fit together? What are all the pieces? So it really starts out with this concept of an environment. So the environment is going to be your virtual network boundary. And essentially, I want you to think of like, if you're coming from the Kubernetes world, I would say an environment is sort of analogous to a Kubernetes namespace. So it manages related services. They're deployed to the same virtual network. If they're using Dapper, they can all communicate via those Dapper sidecars and share Dapper components and configuration. And then all of the logging for containers that are within the same environment will have the same destination. So if you want all of those logs going to the same log analytics workspace, that would be another example of when you would deploy them to the same environment. Maybe you want to deploy to different environments to ensure that two applications never share the same compute or they don't communicate with each other via Dapper. That's when you would potentially consider segmenting them by environment. So within an environment, we have our container app. And I want you to think of the container app as being the core application microservice. So, our container app will be, if I have an order service microservice, it is going to be in its own container app. If I have basket, if I have inventory, those will all be separate container apps within the same environment. And then a container app can have multiple revisions. So there's two modes that you can run your container app in. One is single revision mode, which just means anytime I change my container app, it's just going to update the existing one and I'll have a single revision. If I have multi-revision mode, that means anytime I make certain changes like, changes to an image or to environment variables, it will actually create a second revision. So you'll have, revision A running, revision B running. You can choose to traffic split, and you can choose, settings like that. But you could essentially have, multiple replicas running revisions running in multi-revision mode.
Kendall, just a quick question here from Richard. So the concept of environments, that's new, right, for this service? It's not nothing. It's not a existing Kubernetes concept that you're referring to.
Yeah, exactly. So like from a past perspective, I'm giving you, because I know a lot of y'all have a development background and are probably somewhat familiar with Kubernetes and containers, I'm giving you a little bit of insight into sort of like how you would translate that thought process. But yes, like there's no concept, for example, in container apps of like namespaces or like pods, right? Like you'll never declare a pod, you'll never declare a namespace. These are all things that are abstracted completely away from you. So the concept that you'll see is an environment, container app, revisions, and replicas. Like that's sort of the core concepts that you'll be familiar with. In the back end, for example, a replica is backed by, like a pod deployment, but we don't necessarily ever, enforce that customers need to be aware of this, with the goal of obviously simplifying the Kubernetes knowledge that customers have to have in order to be successful on the platform. So you can have multiple revisions if you're in multiple revision mode, and then each of those can scale. So that's what the replicas are, right? Like I can run multiple instances of revision 1, multiple instances of a revision 2, all based on, whatever my scale rules are that are configured. And then obviously container app 1 and container app 2 can communicate with each other within the cluster, so on and so forth. Now, the only thing I want to call out here, maybe beyond that, is that you see multiple containers within a replica, and that's because we do support sidecar containers. So, within a particular replica, that's going to be your scale unit. So like, for example, if you have your core application code and then you had some kind of sidecar that was doing some kind of like log shipping or ancillary behavior that's modifying the core, behavior of your core container, that's what you would deploy together in a replica. And you can define those together in your manifest. Okay, awesome. Like, and I talked about ingress, right? We do, automatic ingress for you. So we'll generate an FQDN or an endpoint for your container app and for your replicas, and for the revisions. And then we do the traffic splitting across that within an environment.
Okay, Kendall, I had a question for you regarding sidecar containers. Is there some limit to the number of sidecars you can have? Like, can I have Dapper and my own sidecar container?
Yeah, so we actually don't expose you to the Dapper sidecar. Like you don't explicitly have to inject the sidecar or anything like that. So if you were doing a Dapper deployment, you would still only have one one container that you're deploying to the container app, and then just enabling Dapper will handle the sidecar injection. I don't know if we specify you can only run, three containers maximum within a container app deployment, but that's a great question, and I can definitely reach back to the team, but I'm not sure of any specific limits that we set.
Thank you.
Yeah. And I think part of that too, Sujit, would be a bit at the mercy of our CPU profiles, because we only allow containers with certain CPU and I think memory thresholds. So if you ran a lot of containers, even if we didn't have a specified threshold, you'd have to be cognizant of the ability for them to actually function within the confines of those limits. Okay, awesome. So we do just a couple more things to point out on ingress. So we do support TLS termination. We support HTTP 1.1 and HTTP 2. Endpoints always use TLS 1.2, which is terminated at the ingress point, which is going to be Envoy. And then basically all of the endpoints are always exposed on ports 80 for HTTP and 443 for HTTPS. So by default, we will forward all HTTP requests to HTTPS. So we do an automatic redirect from HTTP to HTTPS. If this is something that you don't want, then you can't allow insecure traffic, and we do allow you to specify that. Now, one of the things to think about is that VNet boundary that I talked about earlier. So one of the things that we released most recently was bring your own virtual network. So you can integrate your Azure Container Apps environment with your existing Azure Virtual Network in order to lock down the environment. So there are a couple of different deployment options. One is without bring your own VNet, where we manage all of the networking on the Microsoft side. And then there's the bring your own virtual network, external or internal. So what that means is if I create bring your own VNet external, it means it still has a public IP. So you're going to get an Azure load balancer with a public IP address that's provisioned so that customers can hit the front in like the front end or the ingress point, and then you can do all of the traffic routing from there. That's handled by us. And then the other option is internal only, which means I want to not only integrate with my virtual network, I actually also want to lock down the ingress IP to an internal load balancer. So it will not have a public IP address, therefore it will not be accessible from the external internet or the outside, the outside world from outside of your VNet. So I do want to call out, and I'll get to the question in just a second, Richard. I do want to call out, this will have some nuances with your container app deployments. So this is a quick demo, so I'm going to try to keep my talk track in line with this. So we start by creating a virtual network here. This is an internal example. So we start by creating the virtual network, and let me see if I can, sorry. Let me see if I can play this. Oh, here we go. So we start by creating the virtual network here, and then within that virtual network, we create a couple of subnets that are used by your environment. We're actually working to eliminate one of those or make it optional so that you only have to provide a single subnet. And we're working to also bring down some of the VNet sizes. So right now we require 2/21 subnets for VNet integration, which isn't ideal if you don't need that kind of scale. So we are going to make one of the VNets optional, and then the other will allow you to provide, the minimum number of IPs, as long as you recognize, right, like that you can't extend that that size once it's been created. So if your environment is created and you provide 400 IP addresses, for example, then that's great. And if you're going to operate within that capacity, all good. If you, for whatever reason, needed to scale beyond 400, you'd have to re-provision a new environment and a new subnet. And that's really more just the way that Azure networking and AKS works, and not as much just specific to container apps. So we create a couple of subnets. I also created another subnet within the same VNet for a VM deployment so that I could use it as a jump box. And then we're basically going to get some information about the VNet ID, the control plane subnet, the app subnet, and like I said, one of those will be optional moving forward. And then we create the environment. So I want you to take a look at this bottom CLI command, and I apologize, it's probably a little small for those of you who are watching. But within this container app environment command, I pass in the name of the environment, the resource group, and then you can see here that I have an internal only flag. It's one of the parameters there. So the internal only is specifying that I want this to be created with an internal load balancer IP so that it's not externally accessible from the public internet. I pass in some information around the subnet that I want to use. I pass in the log analytics workspace for observability purposes, and then I pass in a few other necessary parameters like location. And I think my computer is frozen, so let's see if it lets me continue. So it's not going to. I'm going to stop presenting just for a second, just because it looks like my PowerPoint is frozen. So I'm gonna quit really quick and reopen it, and then I'll answer some questions. So the biggest call out there, and I'm not fully done with that demonstration, but the biggest thing there is the internal only. So what that means is, let's say that yeah, exactly, Apple gremlins. Let's say that I provision an environment that's internal only. So if I create a container app, then what does that mean from an ingress perspective? So I'll have two options. I can make, and let's go back to the order service one. So I have an internal only environment and I deploy my order service as a container app within the environment. I'll have two options. I can expose that order service externally to the VNet. So only callers from, callers from the VNet can call into my container app, and callers from my container app environment. Or I can isolate it to just the environment. So that would mean only other container apps can call this particular service. If I'm deploying without the internal only flag, then I'll have the option to basically say I want to expose it externally, which means to the public internet, any caller from the VNet and the environment, or I can isolate it specifically to the environment, which means I only want, callers within the same environment to be able to hit that endpoint. So hopefully that's helpful and gives you a little bit of insight. And I'm bringing this back up. So let me know when y'all can see it. And I know we have 15 minutes left, so I'll make this last part.
Do you want to tackle Richard's question in the meanwhile?
Yeah, I will do that. So where does AAD sit here to limit activity to a container via authorization or managed identity? So managed identity, great question. We are bringing managed identity within the next couple of weeks. So what that'll mean is a container app actually has a unique Azure identity itself. So unlike, Kubernetes, where you think, oh, I deploy a pod and then I can use like pod identity, instead, it'll be like I create a container app, and that container app is a first-class citizen within Azure. And therefore, I could use managed identity from my container app to talk to Service Bus or talk to Azure Storage. So great question. Okay, a couple more things here. So we already created the VNet before. We can see that the environment was created here. I think, let's see. Yeah, so we did the environment create. That's running. Environment gets created. Sweet. Once the environment's created with an internal only flag, we have a default domain and we have a static IP address that get assigned. So you can see here, the default domain is the domain that we provide to you. So you can query that default domain. In this case, it was thankful.c. And then I also am getting the static IP address of the internal load balancer. Once I have those two things, and I restarted it. Once I have those two things, I can essentially set up a private DNS zone that will associate that domain and that IP address with my subnet and or with my VNet. And then basically when any traffic, we can create a DNS rule that says, hey, when any traffic is destined for my my domain with a wildcard, because it would be anything that's destined for the domain, I can actually then send to that static IP address. And then basically what you see me doing here is I created a VM within another subnet in the same VNet, and I externally exposed my container app. So you can see here is where I'm actually deploying, and I want to show there really quickly. This is the actual container app deployment. So at this point, I have an internal only environment. I have like a private DNS zone that's created that I've associated with my default domain for the container app environment and the public IP address. The static internal IP address. And then I'm creating a container app using my weather app demo, just like a basic C# API. And I'm passing in some information about the container image, the port that I want to expose my app on, and I'm giving it ingress external, which means other callers within the VNet should be able to access it. And then from there, what we should see is once I log into that VM, I can then hit that external that external endpoint, aka the VNet endpoint, and I can get my API call. So you can see here my call was successful. So I'm in a VM in the VM subnet of the same VNet where my container app environment is, and then I curl my auto-generated FQDN that was given to me through the managed ingress. And then what I'm going to do is I'm going to update this to internal, which means only other callers within the container app environment can call the API. So at this point, that means no other communication from the VNet, obviously no public endpoint because we did an internal only environment. So I should see different behavior, which is I don't get anything back, which is exactly what happened. So that's essentially how that happens. So just keep that in mind. That's a little bit there. Also, let's see, ARG, so much old school IP config. I really like the app service type configuration, no IP or other subnet considerations. Yeah, so I guess from an app service perspective, we really follow like ACE v2 if you do bring your own VNet. Obviously, if you don't have the bring your own VNet scenario, then none of this really applies because we handle all of it for you. But if you have to do full isolation, we're more ACE v2, and obviously ACE v3 has been released like recently, but we follow an ACE v2 type of model. Okay, cool. So in summary, here are some of the, here's kind of the high level of what we support in Azure Container Apps. We support microservices, event-driven processing, obviously with Kata being baked into the platform. We have web applications. So I talked about the default domain that gets auto-generated, but we actually do have support coming for custom domains, bring your own certificates, and integrated auth. So this is super exciting, and you can obviously use scale here to scale based on the number of HTTP requests. We have those public API endpoints that you can get traffic splitting on top of, and then we also have background processing, if that's something that you wanted to scale based on CPU or memory. So I'm going to walk y'all through just like a really quick, sample, if that works, and just get some thoughts. I'm curious though, so would y'all rather see a Dapper example or an example of a VNet integrated scenario that has, an app that's calling to a storage? So I'd just be curious. So drop it in the chat if you have like an opinion, and whoever gets there first, or within the first couple, will dictate what we do with these last few minutes. Dapper. Okay, app plus storage. Okay, we have two different ones. How about this? Because we're running low on time, we'll do the app plus storage because it also uses Dapper. So that's what we'll nail that. Okay, so let's just pull up. I'm just going to exit out here, and I'm just going to pull up the Azure portal. So give me just 1 second. Okay, so I'm going to pull up the Azure portal and show y'all something really quick. Now, while I'm doing this, do we have any other questions? Any other top of mind features that you want to know about? Questions about implementation? Feel free to come off mute while this is loading.
Is this ready for production? Is one of the questions out there.
Yeah. Yes, that's a great question. So no, we are currently in preview, so we do not recommend running any production workloads on top of Azure Container Apps. However, we are yes, soon. Yeah, you can expect it fairly soon. We're not giving any specific dates right now, but I will say that we are definitely working toward GA. And the more customer feedback that we can receive, the better that we can align with that GA date. But we're in the middle of planning, and I can definitely show you I think I just exited out, but I think here are a few of the things that we're working toward that we really feel need to be available before we could GA for the majority of enterprise customers. So for example, we have here VNet integration, custom domains, which is coming soon, managed identity, enhanced log experience. So we're doing log streaming. We're going to have an exec experience where you can actually do you can have an exec container that's running in the cluster to do some visibility, or to get some visibility and some improved diagnosability as well. Support for gRPC and Dapper, that's coming next week. We have a VS Code extension coming, as well as a VS Enterprise integration. We're enhancing GitHub Actions. We're going to remove some of these quotas. We're doing a big CLI change and a breaking change to some of our Bicep and ARM deployments. We're doing custom readiness and liveness probes. So there's so many things that we're currently working on. A lot of these are already in progress, but these are things we feel customers have let us know that we need before they can go GA with the service. But I would love to hear any other feedback. If you're working on this, if you're working on things that you think this would be a good fit for, and you have other things that you're hey, we would really need this kind of feature before GA, that would be interesting. Will this be supported on Azure Stack HCI or Arc? So we're exploring, possibilities for how this could be ported to Kubernetes or open source. There's a lot of, possibility, right? But we don't have any answers around the Arc integration at this point. It's not currently something that's going to be there when we go GA, but it's definitely not off the table. So, if there's feedback around this and we see a customer need, it's certainly something we would consider. So app dev for next 6 months will dovetail to a prod deployment. I don't know what you mean by that, Richard, but you'll have to let me know. How big is the team? I don't know the exact number of people we have on the team, but it's growing. We now have three primary product managers, myself being one of them. We hired a couple more within the past couple of weeks. And then Daria, my manager, oversees this product and Azure Static Web Apps. And then we have a pretty large engineering team in Seattle. We're hiring some in Austin. So if you're interested and you're an engineer, we're hiring in Austin to work on the product. And then we also have some overseas resources as well. Okay, awesome. So we have 4 minutes. So I'm just gonna razzle dazzle you all with with a few little things from a demo perspective. Let's see how much I can get in 3 minutes, and then I'll answer the last couple of questions that are in the chat. So I have this VNet demo. I already explained to you how it was deployed. So you've already seen it has, the required subnets. I had a VM that's deployed in one of the subnets within the VNet. And then I have my environment that has internal only setup, which means it has no public endpoint. And then I have a couple of other apps that are deployed here. One is a Python app. This app doesn't have any ingress enabled at all because it has no API endpoints. So it's essentially just calling the Node app. And if we take a look at App Insights, you can actually use the Dapper instrumentation key, because I'm using Dapper for this demo, to connect to Azure Storage. And it'll actually show us an application map and all of the calls that have been streaming and the traffic that are coming through. So this is just an example of how you can get some of that distributed tracing capability through Dapper. So we'll see if this loads. While it's loading, is there support for Terraform? Terraform support is planned before we go GA. So it's a great question, and certainly something that we are actively working on, especially as we make changes to our resource provider. We just want to make sure that we make that investment when the product is more stable, or at least some of the decisions are more stable that we made. So you can see here I have the average call time. I can see my Python app only has a single instance running, calling a single instance of the Node app. And we can see some insight around like the tracing. We can see that it's calling out to a state store via Dapper. So this is something cool, and I could drill in here and see logs and all that, but we only have 1 more minute according to the time limit that I set for myself. So the Python app is the caller just generating API calls to the Node app. And what's neat is the Node app is basically taking orders from the Python app and outputting them to a state store using Dapper. One of the things we've added recently is some metrics visibility, so you can get a little bit more insight into network, CPU, and I think we'll continue to enhance this experience. You can see that I get an auto-generated FQDN with an internal flag because my Node app is internal only. That means it can't be called by any caller from the VNet or publicly. It's completely internal to the environment itself. So only the Python app can call it. And if I look at my logs here, what I should see is that we have successful persistence of all of the orders into Azure Storage. And I only have one more thing to show after this. And I should have some pre-canned log queries here. So let's go ahead and run this, and we'll get a quick view. So we're currently doing integration with log analytics for logs. We are working on log streaming, as I mentioned. You can see here I have over 227,000 orders. I should probably kill this demo. Sorry to Microsoft, that pays for my internal subscription. But you can see here I'm getting an order like every 5 seconds or so, and it's successfully persisting. What's super neat is I can look at my storage account, and I have 1 minute left. So I'm still on track. And if I look at my storage account that it's using, this storage account is completely limited to the subnet that my container app is running in. So if you are an enterprise, for enterprise customers who are running in lockdown scenarios, I can look at my networking blade, and I should be able to see that I have only certain virtual networks that can access my storage account. So you can see here, I'm doing selected networks, VNet demo, control plane. This is the subnet where my container app IPs are coming from. And if I wanted to turn this off, I could just use a private endpoint. So I can also create a private endpoint and say, hey, I want my container app to talk to storage using private endpoint. So if we look here, you can see that it's actually working because we'll have that's okay. Just do a quick refresh. I can see that my container should be getting populated by orders. So you can see here the last one was at 6 o'clock, which means I'm out of time. So I'll actually send y'all the Dapper sample that you can use to deploy this yourself and actually see the code, because we didn't get quite there. But thanks for the great questions. Let's see. You're the only presenter that I don't wish for a live video speed up option. Oh, thank you so much. That's super nice. Well, thank you all so much. Sajit, thanks for organizing. Thank you for listening. I appreciate all the great questions. Please stay in touch. Yes, I will send the slides to Sajit. I'll also send over the link to our GitHub repo. If you just want to do a quick search, it's github.com. I think it's azure.container.apps. It's something like that. that might not be exactly it, but you can Google or Bing it. And we have a Discord channel that you can join. We have a mailing list that you can join. You can publicly post any issues to our GitHub repo, any feature requests that you have. We would love to hear all the feedback.
It's awesome, Kendall. Thank you so much.
Thank
Excellent
you.
presentation and good demos as well.
Yeah, and y'all are in good hands with Sajid taking this group over. He's absolutely amazing, and I know that you're going to have a lot of great topics on. So kudos, Sajid, and congrats on this.
Thank you. Looking forward to seeing everybody in person sometime soon in the office. Thank you again, all.
Bye. See you later.
Take care.